In this video, we're going to try and find the derivative of parametric curves. So let's say you've been given these parametric equations, and let's say the particle starts here at time 0. So as you increase time, the particle will move along this path. So let's say the particle is currently here at time t. So you finding out the derivative at time t is really you trying to find out the gradient of this tangent line. So let's say the particle is moving along here, and then by the time it gets to t2, you finding out the derivative at time t2 is really you finding out the gradient of this tangent line. So you finding out the derivative is really you finding out the dy by dx, because this is your x-axis, this is your y-axis. So you finding out the derivative, it's really you finding out dy by dx. But the problem with parametric equations is that everything is driven by time, by this t. So here you've got you input a time, and then it will then tell you the x coordinate. It will then tell you the y coordinate. So we are trying to find dy by dx. But the problem with parametric equations is that everything is driven by time. So once you've got your time, then this here will tell you your x coordinate, and then this here will tell you your y coordinate. To find dy by dx, the trick is to be able to write y in terms of x. So the trick to finding out the derivative is to be able to write y as a function of x. So currently what we've got here is that, bear with me, currently what we've got here is that time drives everything. So when you input a time, this will then give you your x coordinate, and then this will give you your y coordinate. But you are trying to find dy by dx, but everything is being driven by the time. So in order to find dy by dx, we have to find a way of expressing, well, when we input an x, we have to find a way of getting from x straight to y without. So currently here we've got, you start at time, and then from time you can get your x coordinate, you can get your y coordinate. But in order for us to find dy by dx, we have to be able to jump from the x straight to the y. Okay, so we need to be able to do this. We need to be able to write y in terms of some sort of function which we don't know, some sort of function acting on x. So we want to be able to jump from here straight to here. Once we've done this, once we can understand, or once we can do this, then we can once we can do this. This is our aim. We want to be able to express y in terms of x, some sort of function. So we want to be able to input an x in such a way that we're going to do some stuff, and then it will give us a y. We want to be able to do this. Once we can do this, then we can use our mathematical magic to get to this thing here. And this thing here is your dy by dx. But I will explain this another time. But for the time being, our first aim is to be able to do this here. So let me give you an example. Let me give you an example. So let's say we've been given these parametric equations here. This here doesn't give you this path, but let's just pretend that the particle is actually moving along here. This here won't give us this path, but let's just pretend. So what we've got here is that you input a time. You remember, everything is driven by time. So you input a time. So you input 2 here. So so following this, the x coordinate will be 4. So at time 2, the particle will be here, meaning that at time 2, when your time is 2, when your time is 2, then you will get this. You will get When time is 2, your x coordinate will be will be 4. So when time is 2, this will be 4. So when time is 2, this will be, when time is 2 here, the y coordinate will be 12. So so us trying to obtain this is really us trying to find a way of, it's us trying to find a machine in such a way that when we put 4 into the machine, it will spit out the number 12. So let's look at time when time equals 3. Let's look at a time when it's 3. That's this point here. So when you input 3, when time is 3, you input, well, when time is 3, if you input 3, then following this, the x coordinate will be 6. When you input time as 3, this here will be 27. So it's you trying to do this. It's really you trying to find a machine or function in such a way that when you input 6, you will get a 27 out. So what is the function here that will allow us to jump from 4 to 12? Well, what we're trying to do here is that when you input time, this thing here will then give us our x coordinate, and then this thing here will give us our y coordinate. But in order for us to find dy by dx, we need to be able to do this, meaning we need to be able to get to y in terms of x, meaning we need to, when given x, we can jump straight to the y. That is our aim at the moment. We want to be able to when given x, we can jump straight to y. So our first step is to try and understand this. I will continue in the next video, but in the meantime, for this example here, try to find a function that will allow you to jump from x, that will allow you to jump from 4 to 12. Try to find, it will be the same function. Try to find a function in such a way that when you input 6, it will jump to 27. So try to find a function here in such a way that when you input 4, it will give you 12. When you input 6, it will give you a 27. I will tell you the answer in the next video. Okay?